Alright, welcome back everyone. So we're back in our Google Colabs workspace, and I thought I'd just give a quick practical example of the code base and a practical project using all of the different methods such as NumPy, Pandas, Sklearn, Matplot libraries, etc. A practical example so you can see everything in action. Alright, so in this example we're going to import our datasets, and I've created here a dummy dataset essentially describing how many people buy pizzas in London each week. And so we pre-process and clean the data. We, in this example, also split the data into a training and test set of 80 to 20, and we train the model using k to the nearest neighbors, and we evaluate the data. So first of all, we're importing, for example, all our libraries such as NumPy for our numerical operations, Pandas for our data manipulation. We're importing Sklearn model selection for our train and test split set. We are also importing from sklearn.neighbors method, and we're getting our k nearest neighbors regressor for our regression using k to the nearest neighbors. We're also importing our sklearn.metrics method, and from there we are getting our metrics evaluation, and we're going to be using r squared for this. And we're importing our matplot libraries from pyplot, and we're going to be importing that as plt. So whenever we want to use matplot libraries, we'll be using plt dot blah blah blah. Okay, so we just defined a few variables here. So I've just defined the number of weeks for the dataset is equal to 100. Generate a sequence of week numbers like so. So we're going to say weeks is equal to the number dot arrange. Alright, so we're going to be appending each time. So numpy dot arrange on weeks. Okay, and then we're going to generate a base number of pizzas sold with some random noise, just some random data, and we use the dot random method. Alright, next we're going to add a potential trend. So we want a slight increase over time. So pizza sold, we're going to have pizza sold variable, and we're going to try create a trend of a slight increase over time. So I've done that by equaling it to this variable here, base pizza sold plus weeks times 2. And so we ensure the number of pizzas sold is also not negative, like so, making sure pizza sold is always greater than 0. Next, we create a pandas data frame for the generated data. We do that like so. So data equals, remember this PD is how we've imported panda as PD. Alright, import panda as PD. So when you see NP, this for example stands for NumPy, and we're using different methods in relation to the panda data frame. So we've got panda data frame is equal to weeks. So we've got a column for weeks, and we've got a column for pizza sold. Okay. Next up, we've got some data pre-processing and cleaning. So we check for missing values in the data frame, and if there's any, we print missing values before cleaning, and we print this data.insol.sum is how we check for any missing values. Okay, so although our generated data has no missing values, here's how you typically handle them with a fill, mean or median, data pizza sold, fill in NA, data pizzas sold.mean, in place equals true. Alright, so if we want to use our mean method to fill in any missing values, we do it with this line of code like so. If we want to check for duplicates, then we would do it with this line of code just here. Okay, to convert a week column to a feature format suitable for the model, and reshape week to be a 2D array, as scikit-learn models are expecting a 2D array, we do so like the following. So we've got x and y, so 2 dimensions, like so, and define the target variable pizzas sold, like so. Next, we have some data splitting. So we want to split the data into training and test sets. Remember we said 80% for training and 20% for testing. Okay, so we've got x train, x test, y train, y test, and is equal to this train underscore test split variable, and we do so like so. Test size 20%, 0.2, and we need to assign a random state. So a random state ensures reproducibility of the split. Okay, so we assign a random state to a number of 42, so we can assign that to a number of whatever we want. Next, we print the shapes of the resulting sets. Okay, now we have some model training. Our model, we decide to use k-in nearest neighbors, so we need to initialize the k-n regressor model, and n_neighbors is going to be the number of neighbors to consider that can be tuned. Okay, so we've got 5 in this case. Alright, 5 sets, and we do so, load the model up like so. To train the model, we do knn model.fit. We do training the 2 dimensions, x train and y train, as seen above. Okay. Next, we've got our model evaluation. So we want to make predictions on a test set, so we simply use this method here of .predict. Okay. Evaluate the model using the mean squared error method, and we do so like so. So mean square MSE measures the average square difference between actual and predicted values. Okay, like so, predicted and actual values. Next, we want to evaluate the model using R squared, the coefficient of determination. Alright, and so R squared represents the proportional variance in the dependent variable that is predicted from the independent variables. Okay, as we have discussed previously, and so we implement that like so. Alright, and now I've included the matplot libraries. Remember, we've imported this as PLT, so to use it we don't have to type matplot libraries every time, but PLT. Okay, and so these are some different methods or manipulation tactics that we can use in PLT, such as having a title, and I've set the title to actual versus predicted pizzas sold, KNN. On the X label, I've labeled it week number. On the Y label, I've labeled it number of pizzas sold, etc., etc. We're showing a legend, we're showing a grid. We want to show and display the plot by using plt.show. Okay, we've color coded the scatter diagram with blue and red. Okay, for actual pizzas versus predicted pizzas sold. Okay, and I've done the same here for different graph. Okay, and that is pretty much it. Okay, and so when we run this piece of code, this is what we get. You see we have no missing values before cleaning. Okay, we've got the shape of our training, so we've got 80:1 split, a 20:1 split, 80:20. Okay, we've got our mean squared error, and we've got our R squared here, and so on height here we are showing the model here. So blue, we've indicated is actual pizza sold, red is predicted pizza sold. We've got our title up here as specified, and so you can see our plot here, and we can also see our KNN regression model here, indicated by this line here, our KNN prediction curve, and this is the blue dots represent all the training data. Okay, so here is a practical example of how we can use all of what we've learnt, and I hope that's clear. And just remember that with practice makes perfect, and programming is all about continuous learning. So of course during our lessons we haven't gone over, for example, each of the methods such as .random, .normal. We've looked at, for example, .arrange, and so forth and so forth. And so simply with a quick Google search or a ChatGPT search or large language model search nowadays, you can quite easily find out what each of these methods do. Or yeah, that's what I would recommend. If you want to know a lot of the common methods, you can just type in matplot library common methods, and run a quick search on that to figure out what each of the methods do. But in terms of the basic principles and knowing what each toolkit is used for, each algorithm, when to use each one, these are the key concepts that you need to understand for machine learning. And since now that you have this, you should be more than equipped to go ahead and start building your own different models. Okay, but I just wanted to give you an idea of the format of how we of how we essentially would go about doing that. Okay, so we've imported all the methods, we've labeled and created our variables here. Okay, we've imported our pandas, we've done some pre-processing, we split the data up, we trained the model, we evaluated the model, and we put some nice visualization of the model for the results using the matplot libraries. Okay, so it's as simple as that. Give it a go, try it out yourself, and I'll see you over in the next lesson. Bye bye.